Okay, so I'm going to show you arc length for polar coordinates. So assuming that f prime is continuous, then the length L is the integral from a to b of the square root of dx d theta squared plus dy d theta squared d theta. Okay? Now, how do I even get x? Or how do I get y? Well, recall that x is equal to r cosine theta and y is equal to r sine theta. Okay? So if I'm going to take the derivative of this dd theta, we'll do it on both sides. And so what do I get? Well, I get dx d theta, which is what I want, equal to, well, this is a product. So the product says the first times the derivative of the second, negative sine theta, plus the second cosine theta times the derivative of the first dr d theta. Taking the derivative implicitly. Okay? So I'm going to do the same thing over here. dd theta and so this is dy d theta is equal to the first times the derivative of second cosine theta plus the second sine theta times the derivative of the first dr d theta. Okay? And now what do I want to do? I want to do this inside piece right here. So I'm going to square each of these and then add them together. So dx d theta plus dy d theta all squared okay. What in the world do I get here? So I'm going to get a big old mess. Okay. So I'm going to get r times sine, negative sine times r times sine. So both of those are negative. They cancel. So it's r squared sine squared theta. And then minus, there's a negative here and a positive there. So there's minus and then a double copy r dr d theta sine theta cosine theta. I'm literally, look guys, if I'm doing this x plus y squared, that's x plus y times x plus y, right? That's equal to x squared plus 2xy plus y squared. So that's where that 2's coming into play. It's negative because there's a minus going on there. And that's where that squared is coming into play there. So if you're wondering what's going, it's like, what in the world's going on, Mr. Clark? I'm literally squaring this here, okay? And then plus cosine squared theta times dr d theta squared, okay? Now I'm going to do plus r squared cosine squared theta plus 2r dr d theta sine theta cosine theta plus sine squared theta dr d theta squared. Okay? Now I'm going to group the terms together that have dr d theta squared. Okay, so that's dr d theta squared. And so what is that? That's a cosine and a sine. So that's cosine squared theta plus 1. I'm sorry, sine squared theta. All right. And then I'm going to group the terms that have an r squared in them. R squared here and an r squared there. So I'm going to factor that out, and I have a sine squared theta and a cosine squared theta. Okay. And then what does that leave me? Well, that leaves me a negative 2r dr d theta sine theta cosine theta and a positive 2r dr d theta sine theta cosine theta. So those cancel each other. They just go away. Okay? So now what do I know? I know this is 1 and this is 1. So this simplifies to dr d theta squared plus r squared. Pretty simple, right? Pretty amazing. So what does that tell me? That tells me that this can replace what's in there. And so my arc length is summed up. It's L equals the integral from A to B. So if you haven't understood anything from up to this point, now check in, right? So square root of r squared plus dr d theta squared d theta. Okay? And so this is the formula that's going on here. All right, so hardest part of this problem, I think, is just multiplying this out, and literally, like, you just write it out. You just got to write it out twice and multiply it. Okay, you're literally you're distributing the FOIL that you did in college algebra. And when you fold it out, you end up getting that nasty thing there. And then you do the same thing again here. And then when you collect like terms, you're literally just coming through and factoring out the r. See, if you had this here, the r squared sine squared theta, and then the plus r squared cosine squared theta. And instead of, writing that, I just skipped that. I factored the r squared out. But if I factored the r squared out, then that leaves that sine squared theta plus cosine squared theta here. So that's where this term is coming from. Same thing for that other piece over there. Okay? But if you don't understand all that, that's okay. Because this is what you need in order to do arc length for polar curves. You need the function and you need its derivative. And that's it. So example to show you how easy this is. I'm going to find the length of the cardioid. R equals 1 plus sine theta. Okay, r plus 1 sine theta. So that's that same cardioid we've been drawing. Upside down heart going on. And I want to figure out how long is this curve here. Okay, so to do this, not only do I need r, but I also need dr d theta. So I take the derivative with respect to theta. The derivative with respect to theta of 1 is 0. The derivative of sine theta is cosine theta. Okay? So it's just cosine theta for the dr d theta. And so now I'm going to do integral from a to b. Well, a starts at a equal to 0, and I go all the way around to b equal to 2 pi. So 0 to 2 pi, square root of r, which is 1 plus sine theta, squared, plus drd theta, which is cosine theta squared, and then d theta. If I do some algebra to simplify, or trig, I guess, this would be 1 plus 2 sine theta plus sine squared theta plus cosine squared theta, d theta. What do you know about sine theta, or sine squared theta and cosine squared theta? Those add up to 1, the Pythagorean identity. So I have 1 and 1 make 2. So this is 2 plus 2 sine theta d theta. Okay? And at this point, I would throw it in my calculator, since you don't have a trick to get that integral. So math 9, 0 to 2. Come on, what happened? Okay, just clear it out. Math 9, 0 to 2 pi. Oh my gosh, fat fingered that. 0 to 2 pi. Don't click the clear button, that stinks. And then 2 plus 2 sine x, close parentheses. All right, hit enter, and you get 8. Wow, 8. So that weird looking curve has a length of 8 units. Pretty cool. Pretty cool.